Okay, so the big things that we really need to know so far that we haven't gone over, the things we've gone over in detail are to convert pitch to slope. So if we have a 3/4 pitch, how do we turn that into a slope? So 3/4 times 24, which is going to be what, 18? That's an 18/12 slope. Or we might have, more commonly, a 1/6 pitch. What are we going to do with that? 1/6 times 24 is going to be 4. So it's going to be a 4/12 slope. We might have convert slope to pitch. If you're setting a ridge beam, it's handier to have it as a pitch. 3/12 slope. What are we going to do? 3/12 times 24 ends up being 6. Oops, I don't know where that 20 came from. Let's try that again. 3/12 times 24 is what? Sorry, I did that wrong. Let me try that again. Yes, you did. You're correct. You take the top number of the 3, you put it over 24, that reduced to a 1/8 pitch. Thank you. I don't know why I was going backwards there for a minute, but I was. Or if you have a 12/12 slope. Careful, everybody wants to call it a 1 pitch, but it's not. You take the 12 off the top, it's 12 over 24, which reduces to 1/2. That is a 1/2 pitch. 24/12 would be a 1 pitch, yes. You should be pretty good at finding the length of the common given a run of 16 feet and an 8/12 slope. Tell me what I do. 8/12, what's the number for 8/12? 14.42, and you guys can get the decimal. 16 times 14.42. 230, we're going to divide by 12 to get feet. 19 feet minus 19 times 12, take it back to inches. Careful, I screwed up. So now we're back. So it's 2.72 inches, right? So it's 2 inches, subtract 2. Times 16. 11.52, so that's 12, so that's 3/4. 19 feet, 2 3/4. Or you might be given a span of 38 feet and a pitch of 1/4. First thing we got to do is 1/4 times 24 is a 6/12 slope. The run is going to be 19 feet. So it's going to be 19 times 13.42, which is 254. You guys can go from there, right? Anybody not sure how to go from there to get feet, inches, and sixteenths? Good news. Quiz. If you're still working on the quiz, Feel free to take as much time as you need to finish up. We're going to go ahead and start on some of our new material here. What we're going to look at today, now that we've covered some of the measurement stuff, and we've worked a little bit with dealing with the square, we're going to go back into something a little pure math and a little less construction. We're going to look at volumes. We've talked about areas. And when we talked about areas, remember, we had to build them up from that idea of a point, that location. And when we took that point and we pulled it in a single direction, what did we call the distance that we pulled that point? That distance was equal to the length of that line segment. And again, for purposes, we're just going to call it a line, because in construction they call it a line, even though it does not go on forever in each direction. So then next, we take that line and we pull it in a second direction. And remember, the direction that we pull it has to be perpendicular to that original direction. That doesn't mean it has to move perpendicular, but there were two conditions. It had to stay parallel, and the distance it moves has to be measured perpendicular. So we're just going to go ahead and move perpendicular like that. And that creates a two-dimensional object. Notice two directions of pull, two dimensions in our object. And that area was defined to be the original length times that distance it was pulled in the second direction. And quite often that distance was referred to as a width if it was a rectangle. If it's not a rectangle, of course, it is purely a distance. Here, if we're assuming that this is a rectangle and these are right angles, the area was, of course, let's say this is 16 inches and 5 inches. The area was simply 16 inches times 5 inches, or 80 square inches. But we saw that it did not have to be perpendicular. We could pull it like this. Oops. Cut that off a little bit, where if this is still 16 inches, what matters is the distance from where it started to where it stopped. Even though it didn't get slid perpendicular, the distance is measured perpendicular, and that 5 inches still results in an area of 16 by 5, or 80 square inches. So today we're going the next step. We're going to talk about a volume. So we've already established an area. So there's a rectangle sitting there. We're looking at it kind of from up above and at an angle. That's why it looks like it's kind of off like that, because we're looking at it at a weird angle. That is an area. Just like we took a length and we pulled it to create a volume, we're going to take this area and we're going to pull it, or we took that length, I should say, and pulled it to create an area. We're going to take this area and pull it to create a volume. So the size of this volume is now equal to whatever the size of that original area times this new distance that it was pulled, this new length. So let's say that the base of this is 8 inches by 12 inches. What's that area? Yeah, 12 times 8, or 96 square inches. And let's say it now gets pulled a distance. Oh, let's say that distance it gets pulled is 10 inches. So the volume would be 96 square inches of area times 10 inches of distance, or 960 cubic inches now. Square inches times inches is inches cubed. The area of the base times a distance, or a height in some cases. Now I don't call it a height because it isn't always a height. On a rectangular box like this, you can choose any side to be the base. So we normally choose the bottom to be the base. But the base isn't necessarily the bottom. The base is the shape that that whole object is based off of. And this is the reason why, for a box, we could just define the volume to be length times width times height, which would work for a box, but it would only work for a box. We could run into a shape like this, I don't need that line there. A shape like this, where this is not a box, length times width times height would not work here. And the base of this is not the bottom. The base of this is this triangle right here. Because that is the shape that that the whole object is based off of. It can basically slide through the whole object. So if I wanted to find the volume of this, the first thing I would do is find the area of that base. So let's say that this is 5 inches and this is 14 inches. And let's say this is 20 inches here. Perfect. I do the area of the base is 14 inches times 5 inches divided by 2 because it's a triangle, which is going to give us 35 square inches. And yeah, we are going to take that area of that base, 35 square inches, times 20 inches now to give us 700 inches cubed. What do you think? And this goes on to any shape, anything we can find a volume of. This length right here. So pretend those are circles and that this actually looks like it might be a cylinder. We don't need a separate formula for finding the area of a cylinder. Because that same formula does apply. We can find the area of the base. Well, this is a cylinder. It's got a circle for a base, so pi is going to be involved. It's going to be pi times what? 5 squared. Pi times radius squared. So about 78.5 square inches. So the volume, yeah, will be the 78.5 square inches times 15 inches, which is going to give us 1177.5 inches cubed. Bless you. Any questions? So, this doesn't have to even be a regular shape. We can run. What's that? We're not to that yet. We'll get to that later. Yep. So something like this. How would we approach this? Well, first of all, what's our base? The base is this whole piece right here. Because that's the shape that this thing is based off of. That's the shape that was used to create this. As I said, think of being able to take that shape and pull it through the whole object. So what we have to do is find the area of this base. Well, this base is not... Drew, put the phone away. This base is not a simple shape, so we have to break it down to find its area. Obviously, that half circle has to be cut off, and we're going to cut this across here. Shut the video off, Drew. Drew, shut it off or put it in your pocket. So here we got this here rectangle, which is 14 by 16, which is going to be what? 224, I believe. That'll be square feet. This second one here, which is going to be 8 feet here, where'd the 8 feet come from?
The 14 minus 6.
Perfect. 14 minus 6.
And then 16 minus
24 minus 16 will make 8 feet there as well. So that's 8 by 8, or 64 square feet. Then, of course, this is 4 feet of diameter, or of radius, half of the 8-foot diameter. So that'd be pi times 4 squared divided by 2, which is going to be, what, 25.12 approximately? So that is what? 303.12 square feet of area of the base. Does that look good? Did you get 313? Yep, you're right. 313. .12. So then for volume, we take 313.12 square feet times 20 feet, which is going to give us 6,162.4 cubic feet. What do you think? Oh, sorry, 6,262.4 cubic feet. What do you think? Not terrible. What's that? Feet to the third. Okay, well, I've got a couple I want you guys to try in your notes. Keep telling yourself that. Thank you. Okay, so those are right angles. So that's 12 feet, 16 feet there. 20 feet, 15 feet, and 14 feet high. Find its volume for me. Okay, so area of the base here. I would start out with 20 feet by 15 feet, or 300 square feet. Then subtract out this triangle, which is how big? 4 by 3. So 4 feet by 3 feet divided by 2, because it is a triangle, is 6 square feet. So, hey Drew, don't make me have you leave. You got to quiet down so I can talk. Okay? Yes, sir. Like that? Something like that?
Yeah.
That works. It should get the same total. Should be 15 times 16 would be 180.
15 times 16?
Yep. You did.
They're saying 240.
Okay, you're right. I'm sorry. It's Monday. 240, sorry. This is 12 by 4 here, which is 48. And then this is still 3 by 4. This is 3 by 4 divided by 2, which is 6. That still comes out to 294. Okay. So you got the area. Now for volume, 294 square feet times the 14 feet gives us what? What's that? 4116. How many of you got that? Okay. Well, good news. Okay, not quite yet. Talk about density. Density is the mass of an object divided by its volume. Since we can calculate volume now, we can talk a little bit about density. So if we have something that is 112 cubic inches and has a mass of, oh, I don't know, let's give it something like 28 pounds. How would I find its density? By the way, pounds is not really a mass, but we use it as a mass. 28 pounds divided by 112, which is what, 0.25 pounds per cubic inch is the density. Well, we can use that in other ways as well. Wood. A lot of your wood, does anybody know what the weight per cubic foot of most wood is? 2 pounds. If I remember it, per cubic foot, most wood is like between 50 and 60 pounds. But we'll look it up here just to make you happy. Average dried weight of wood. There we go. Come on. Okay, let's go back. Here it is. So it's like red oak is 45. Red cedar is down around the 25. That's 12% moisture. That's pretty dry.
No, that's an average dry weight. We're supposed to have 8% moisture.
Really?
Yeah.
For your... Because 14 is what your standard construction lumber comes at.
14.
This is the one I was looking for, I think. This is per cubic foot, yeah. So you can see Applewood's 44, ash is about 42. Yeah, so you're looking, looks like it's 25 to 45, 25 to 50, depending on the type of wood.
Walnut.
Walnut? Walnut, black dried walnut is only 38. So let's say that you have wood that is 42 pounds per cubic foot. And for a project you need, for any of your projects, have you guys figured out the board footage you need for your projects yet? No. It's 80 board feet. Let's make it easy. Let's do 84 board feet. The reason I'm using 84 board feet is it takes 12 board feet to create 1 cubic foot. So if I divide by 12, that's 7 cubic feet of wood. Times 42 pounds per cubic foot is going to give you 294 pounds. So if you need 84 board feet, it's going to be 290 pounds about. 84 board feet, though, is quite a bit. And some of that's going to be waste. It's not all going into the objects. In the little book, I want you to work on Unit 26. In the big book, it's going to be page, I've got to find the updated page now for our new edition here. On page 251, 252. On page 251, it's exercise 8-7. And on page 252, it is exercise 8-8. So I'll give you a second to write that down. And I'll give you the last few minutes for your homework.